Hi guys, we're on to the next subject. It's called arrays. We'll talk a little bit about those. The video is going to be a little rough. I am currently in the process of passing a kidney stone, so I am in a lot of pain right now. I took some pain meds that'll help me get through this lecture, and then I'm going to go home, go to bed, and probably end up in the hospital so they can get this thing taken care of. But in any event, let's talk about what's happening with the whole notion of arrays. Okay? I remember years ago when I was programming, when I was first learning to program, and I didn't know really that much about the existence of arrays. My solution for keeping data that was similar together was to just call it a variable name and then some number like x1, x2, x3, x4, x5. And in this case, these are all holding integers. Okay, that's how I organized it in my mind. I didn't think anything more of it. Most computer systems that are out there, rather most programming languages that are out there, will allow you to store these things in what is known as an array. And the way that they handle it is they add a few extra characters to help us keep it organized. Now, I personally don't know at this point if Python will even like such a thing, but it doesn't matter because this is kind of pseudocode right now anyway. Okay? We'll go here like this, and we'll go there like that. And so now what we have is we still have our x, but instead of having just the 1 through 5, what I did was I stuck the 1 through 5 in brackets, in square brackets. This makes it possible for us to kind of store all this stuff together in computer memory, and as you see, I'm getting lots of red marks, which means this is all completely wrong, okay? Which is fine. I don't care about that. For most of you guys, if you're looking at it and you're totally new to arrays, you're saying, well, that was exciting, Dave. You just put brackets around the 1. I'm so happy for you right now, okay? Well, what that did was that made it possible for me to do something like this. I can set I equal to 4, and I can access or print, if I could type print, P-R-I-N-T, I could print literally x open brackets of I. That's what my goal is, okay? But let's talk in a little more detail about these arrays. And I think probably the easiest way might be to try to do a chalkboard, and really I have no idea how well this is going to work because it's the first time I've tried this on the computer, but an array is a collection of data that is similar, okay? It's a collection of data that is similar. Let me move things around just a little bit. In most computer programming languages, arrays can only have one specific type of data in there. We know that integers are a type of data, just like Corvettes are a type of car, right? We know that floating point numbers, are a type of data. We know that characters are a type of data. Strings, on the other hand, though, are in truth an array of characters. In other words, the computer doesn't think of a string in most cases as my name, David, okay? It thinks of my name as, oh, it's an array of characters, D-A-V-I-D. So basically what that comes down to is in memory, okay? I'll just bring up my this critter. Let's see if this will work. There we go. In memory, we have a memory cell, say like this big here, that is capable of holding one character of data, D. That's it. And we have another one, A, V, I, D. And that's all it is just consecutive memory cells. And because we're dealing with a computer and we know that it's only character data, the computer knows to take this portion of the data right here and treat it as a single region in memory that is completely predictable in size. Okay? If a character is a byte, our computer is going to know that we need 1, 2, 3, 4, 5 bytes of memory that are reserved to hold Dave, okay, or David, which is rather cool, all right? So if I want to hold floating point numbers, it might take more memory. So I'll just represent that with a bigger block, okay? Another bigger, more memory kind of a deal. Another bigger, more memory kind of a deal. And so on and so forth, all right? So that's how arrays began. An array is often considered a data structure, okay? Because what we're doing is we are organizing our data right here, you know, this spot right there. Why is that not writing? Oh, there we go. That and that and that and that. These are all organized in a special way inside memory. It has a structure to it. And in this case, the structure is sequential, okay? One right after the other. So we call it a data structure, where before we just simply had x is equal to 1, right? We did x is equal to 1. Well, if x is equal to 1, we only need 1 byte of data to hold x. We'll put x in there, all right? That's really not a data structure per se. That's why we call it primitive data. It directly occupies a single memory cell. Floats are considered, in some camps, a data structure because you divide the number in one memory cell and then the floating point portion, 10 to the x, in some other memory cell, okay? If I can get that to go away, maybe, there we go. So floats, I guess, could be, but for most people they don't consider them a structure. A structure is when we have more than one data element, and here we have, in this case, 4, okay? So we ran into a little bit of a problem though, and that is eventually we wanted to be able to take a bunch of data such as a name, okay, an age. This is really fun to try to do this on the computer. A name, an age, a height, maybe, etc., and kind of package them together. Try that again here. How fun is this, right? So try to package it all together. The data structure has changed a little bit. It's not merely an array. It is a kind of an object, because I want to be able to maybe change the person's name to a different name, or I might want to change their age to a different name, age, or the height to a different height. So I may have some kind of a programming method that works on these guys that changes a name, an age, or a height. And I may put this whole thing together in a single package, okay? That would also be called a data structure or a data type, okay? So a lot of computing programs have decided to abandon arrays altogether and go with what are called lists. You recall that when we talked about the array, each memory cell here, each one of these things had the same type of data, like an int, okay, or a float, or a char. It's going to be some type of primitive data. That's how arrays work, period. They're all going to be ints, they're all going to be floats, or they're all going to be chars. That's it. But what happens if you end up with string data? Remember I said strings are a list of chars, right? So here we go. We have our nice long list of characters. Draw ourselves a little line here to divide up our memory. We have a character here, one here, one here, and one here, right? These are all stored into memory, which means since this is an array, it can't be changed. Once it's put into memory and it is this way, if I try to add to this or remove from it, I am going to crash into this memory cell, and that's going to be a problem. That's why they often say that strings cannot be changed. Strings are immutable. Okay, so mutable means it can be changed. Immutable means that it cannot be changed. So that's where that notion came from. Well, that's no good, right? We need to be able to change our strings. So we've got to come up with a different way of handling these things. And the way that we do that is now, instead of storing everything inside individual memory cells, what we do is if I have a name, for example, okay, there's my handy dandy name, I will store literally an address into my array. Okay, and now my array, instead of being called an array, it becomes what is known as a list. Since this thing here is a memory address, which in turn points to a block of memory that holds whatever we want it to hold, this means now I am not limited to maybe just a string, right? I can, if I want to, I can make it hold something else. I don't know what else I'm going to hold right now. We're at a point in our lives that we don't know that, but we eventually will. Okay? So name actually is capable of holding anything. And I've lost track of my cursor. Oh, there it is. Okay? So we can hold, as I said, strings. We can also, if we wanted to, in truth, we can hold a string of only one character, a string of maybe 2 characters, and so on and so forth. We can hold a special number n. Like if you're in JavaScript, JavaScript doesn't have floats. JavaScript doesn't have integers or long ints or anything like that. It just has what's called a number, and it stores the number in a region of memory over here that has all the stuff that it needs to work on that number. All right, and I realize that might be just a little bit confusing, but the point that I'm trying to make is where arrays are forced to use exactly the same kind of data because each element of the array is the same size. Lists can hold whatever data we want. This first cell can be pointing to a string. This second cell can be pointing to a float. The third cell can be pointing to an int. This cell over here can be pointing to whatever we want it to point to. Okay? So they come in 2 glorious flavors. Now, why do I go through the trouble to tell you about lists and arrays at the same time? Because Python doesn't have arrays at all. It does everything with lists. All right? So let's go ahead and put our handy dandy chalkboard away. And it looks like I've got 12 minutes consumed already, so I'm going to go ahead and stop this portion of the lecture and move on to the next portion.